Hello and welcome to today's LeetCode problem. So as a preface to this video, today I'm going to try out something a little bit different. If you've noticed in watching my previous videos, what I've been doing is figuring out what the solution is and coding it up first, making sure everything is good before I create the video itself. For this video, I'm going to try something new and hopefully beneficial to you guys. I'm going to basically take a look at a problem for the first time on a concept I'm still a little bit unfamiliar with, which is sliding windows, and basically go through what I would usually do if I'd encounter something for the first time. I hope you guys find it useful, and yeah, hello and welcome to today's problem. 1343, number of subarrays of size k and average greater than or equal to the threshold. So you're given an array of integers r and two integers k and threshold, and you want to return the number of subarrays of size k and average greater than or equal to threshold. Okay, so you're given this input over here, 2, 2, 2, 2, 5, 5, 5, 8. K is 3, so you want arrays of size 3, and the threshold is 4. So you want to figure out which subarrays have the average greater than or equal to the threshold. In this case, it's 2, 2, 5, 5, 5, 5, 5, and 5, 5, 8, 8. Because they have averages 4, 5, and 6 respectively. All the other subarrays of size 3 have averages less than 4. Okay, that makes sense. We're given this other example here. 11, 13, 17, 23, 29, 31, 7, 5, 2, 3. And output is 6 because the first 6 subarrays of size 3 have averages greater than 5. So, okay, that makes sense. You want to note that averages are not integers. So 2, 2, 5, 5, 5, 5, 5. Okay, this makes sense. So an idea for how we could do this is by utilizing a sliding window. With the sliding window, what we can do is we can keep in mind what the condition for a valid subarray amount is. So basically the condition is that it's size k and greater than threshold number. And how do we know that? Greater or equal to their averages. Well, what has to be known is that the basically the amount of the subarray, so elms in subarray divided by the length of the subarray, that has to be, if we add all of those elements up together, so sum of elements in subarray, if we add all of those up together and divide by the length of the subarray, that has to be greater or equal than the threshold. And that's the size k has to be, it basically has to be like of size k, which makes sense. Okay, so that makes sense. Another thing we have to look out for is what to return as that final result. We're trying to return the number of subarrays which are meeting this condition. So we'll have a res variable, so result accumulator, which detects valid subarrays. So we'll keep that, return that at the very end, and then basically, yeah. So that makes sense. So my thinking is what we have is a left and a right pointer. So we'll go ahead and do this right now. Let me run through a quick example of what I have in mind. So we have something like this. We have a left and a right pointer. What we can do is have the right pointer keep traversing through the array. So we start off here, we move this forward, we move this forward, we move this forward. Basically, we keep moving it forward until the distance. Well, we know that a subarray is valid if the well, okay. So we have to initialize the pointers. So the first pointer and the last pointer to both to be k elements apart. So we start off, let's say like k is equal to 3. We traverse. First, we traverse right pointer forward by 3, or by k, right? So let's say k in this situation is equal to 3. So we traverse the right pointer forward by 3. So 0, well, set it to 3 actually. Basically 0, 1, 2, well, by k minus 1, including the element. But yeah, so we just basically move it so like the size, like the difference between the right pointer and the left pointer is k. So between r minus l is equal to k. Next thing we have to do is we want to traverse, like we want to start moving the right pointer forward and the left pointer forward as well. So we want to move this here, move this here. While we're moving this forward, what we want to do is we want to check to see whether or not all those elements added up together, so 2, 2, 2, are equal to pretty much like above the threshold. So with elements in window, check if above threshold. Threshold. So for example, we start off at the very beginning. We have 2, 2, 2 over here, and we want to move this forward, right? Move this forward, like basically add up all of these together. 2 plus 2 plus 2 is 6 divided by 3. 6 divided by 3 is 2. So that's not above the threshold, so it's not valid. So check if above threshold with this formula, pretty much, by doing this. If it is above the threshold, what we can do is we can pretty much count that as a valid subarray. Valid subarray add to results. And if it isn't, what we do is we pretty much just traverse the right pointer forward by 1 and traverse the left pointer forward by 1. And from there, what we can do is check to see whether or not those values are valid. So increment L and R by 1, check again. Okay. So yeah, that makes sense. Basically we can keep track of all the elements that are in this by storing these elements, storing the elements in the sliding window in a set. So we can add that as part of the requirements here with elements in window. Okay, so we'll do like 1.5 question here. So traverse right left pointer forward, so differences are minus L equal K. Next thing we have to do is add elements in sliding window onto sets, and then with elements in the window, check if it's above the threshold. If above the threshold, then you add the result. Otherwise, you increment L and R by 1. Remove elements not in window from set, then you want to check again. And basically, we can rinse and repeat this process up until the right pointer reaches the end of the subarray. So if right pointer is basically greater than the length of the array, minus 1 ends the algorithm. So right, some cases we need to watch out for. Let's take a look at the constraints here. So k, it has to be between the length of the start and like it has to be less than the array's length, which is good because otherwise we'd have to check whether or not it is so. Because if it was greater, then we'd have an issue with traversing it forward so that it's equal to k. Okay, so that's good that condition is there. Okay, so all numbers are integers. They have to be within like certain amounts. Okay, that makes sense. Okay, so the time complexity of my current solution, just having this 2 pointers again, and moving forward all the way up until the right pointer reaches the end, it would be O of n, because you're really just traversing these 2 pointers forward. You're not having to like compute multiple operations, and you won't have to like check each instance of that sliding window at once at a time, because we have a set which basically keeps track of all the elements within that sliding window. So it'll be O of n time complexity, and the space complexity would be O of it would be O of k, where k is the number of integers in the sliding window, or like as like the parameter that you pass in, because that's what you're like, those are the maximum amount of numbers you're going to be storing in the memory as you traverse through. Yeah, so I'll go ahead and begin coding this up now. So first thing we're going to need is we're going to have a set. We're going to need that. So we'll have a like maybe like values, or like or an accumulator, pretty much, which contains the values in sliding window. Next thing you're going to have to do is you're going to have the left pointer, which is set to 0, and the right pointer, which we want that. Actually, so we want to set the right pointer to 0, and we want to traverse that so it adds all of the elements onto the set. So yeah, left pointer and right pointer is equal to 0 for now. And yeah, so the first thing we're going to want to do is traverse the right pointer forward so that the difference between r minus l is equal to k. So for, let's see, for I in range k, what we want to do is, or for value, or yeah, I in range k, we want to basically move the right pointer forward by 1. So l or r plus equals 1. And before we do that, what we want to do is we want to add that, we want to add the array at index r. You want to add that value to the set. So we'll do accumulator dot add r, the array at index r, and you want to traverse forward. So that'll be like the first step over here. So we'll go ahead and do that. Next thing you're going to want to do is add elements. Okay, so add, yeah, that's 1.5. So we add the elements in sliding window onto the sets. So at the very end of this, what should be populated for our case, basically we move the right pointer from index 0 to k. So 0, 1, 2, or I guess k minus 1. Yeah, so k minus 1. Yeah, so k, since k is for a loop statement in Python, the k is non-inclusive. So yeah, so for, like what's gonna happen is from 1 to 3, it'll only do 0, 1, and 2, which is what we want. So we'll go ahead and add this to the array and keep incrementing at the very end. That's completing steps 1 and 1.5. With step 2, with the elements in the windows, you want to check if it's above the threshold. So let's say like and we want this to happen as long as the right pointer is greater than the length of the array minus 1. So we'll do while the right pointer, so r, is less than the length of the array minus 1. Yeah, so less than or equal to the length of the array minus 1. What we're going to do is we're going to check and see whether or not the elements in the window are above the threshold. So we'll do that by using the formula that we did here. So if okay, so okay, so yeah. So by so an issue I'm thinking of right now is if for every single while loop you sum up all of the elements together, that's going to be accessing the set a large amount of times. So we're going to want to avoid that. So I'm thinking about how we would modify this. Okay, so maybe what we can have instead of that is we have a cur sum, which is equal to 0. Yeah, so maybe, okay, so instead of adding it to a set over here, we can, instead of having a set, we can have a cur sum, which is equal to basically just 0. So it contains some sum of values in sliding window, what we can do instead is, instead of adding it to a set like this, we can just do add cur sum plus equals the array at index r, pretty much. So we just add up all the values and put them in the current sum. And then from there, what we can do now is check to see whether or not if cur sum divided by k, if that is greater than the greater or equal to the threshold, then that's a valid one. So if that's greater or equal to the threshold, then we want to add to the result, which is result equals 0. We want to add to the result plus 1. So res plus equals 1, and then we want to return that at the very end. Return res. And you want to keep going. If it's not, well, regardless if it's not, what we want to also check, what we also want to do is remove the current element. So, yeah, so we want to increment left and right by 1. So we'll do that first. LR equals L plus 1, R plus 1. So we'll go ahead and add those, increment those values by 1. And then after, well, before we do that, what we can do is we can remove the current elements at L from the current sum. So cur sum minus equal array at the left. And then for cur sum, what we can do is we can add basically, so we want to subtract that from the left, and then we want to add the elements, so cur sum plus equals array at the right. So once we do that, pretty much what this is doing is we start off here, we want to traverse the sliding window forward by 1. So we basically increment both this forward by 1. Before we want to do that, we want to remove this element. So we do like cur sum minus 2. Maybe here. We'll do, so cur sum right now is 2, 4, 6. What this is doing is first removing the elements at the left pointer, so 2, and making that 4, so it subtracts it. And then it traverses both of them forward, so it goes like this. And then it adds the element here onto the current sum, so this becomes 6 again. And basically this is valid. So basically just like move the sliding window forward. And what this does is basically check to see whether or not the condition is valid, whether or not the current sum divided by k is greater or equal to the threshold. If it does, then that's when we add it to the result. Yep. And then otherwise it keeps appending, basically keeps moving the sliding window forward up until the right pointer is basically equal to the length of the array minus 1. At the very end, what it'll do is return the result. Okay, so let's see if there's anything we missed here. Okay, let's run this through again with this example using the code just to check to see if there's anything we missed. Okay, so okay, basically we have the left pointer and the right pointer set to 0, 0, result 0, current sum is 0. For everything up until k, non-inclusive, so this k equals 3, so this would be up to 2, 0, 1, and 2, 0, 1, 2. It moves the right pointer by 1, so plus 1. Oh wait, before it does that, what it does is it sets the cur sum equal to array right pointer, that's 2, plus equals 4 as it moves forward, and then 6, it becomes 6 over here. Okay, so from here, what it does after is it runs the while loop here. It checks to see whether or not the current sum divided by k is greater than or equal to the threshold. And the threshold in this situation is 4. We'll keep a note of that. So 6 divided by 3, basically it's 2, and that's not greater than 4. So this if statement doesn't run. Regardless of whether or not that runs or not, we want to move the sliding window forward before checking again. So current sum, what happens with this one? Basically, we subtract the current sum from the left pointer, so this becomes 4, and then we add then we basically move these forward forward. So we have this, and this becomes 6. And then from here, what happens is, yeah, you increment the right pointer array forward once. You run it again, check to see what's going on here. 6, that's not right. It's still the same thing. So we move this forward and we decrement that becomes 4. We move this forward, this becomes 5. We add this together, so it becomes 4 plus 5, which is 9. Yeah, so 5, 6, 7, 8, 9. That's the right value. We go ahead and check the current sum again. For the new one, check to see if it's greater than the threshold. 9 divided by 3, that's 3. The threshold is 4. Wait, yeah, right. Oh, 255. Yeah, so this isn't valid also. We move this again, check to see. It'll be 4 this time the average. That one's a valid array. So what'll happen is the result will be appended, will have 1 added to it. You keep going forward again. Until eventually the right pointer, what happens is right is at this point 0, 1, 2, 3, 4, 5, 6, 7. R is equal to 7, right? And the length of the array, which is 8, you subtract that by 1, which is 7. It's equal to it. So at this point, the condition is broken. So actually, we also want to check out for this final case as well. So we want to do this as we check out for the final case before returning the result at the very end. So we'll go ahead and run this now. Check to see one last time, and we'll run it to see if there's any issues with it. Okay. So we're getting an output of 2 when there's supposed to be 3. I'm suspecting it has to do with me not including that final value. Okay, I see. So list index out of range. Okay, so this is valid then. Okay, so right, have a look here. Output is 2 when you expect 3. Okay, let's have a look at our logic again. Traverse the right pointer, so the difference between R minus L is K. Okay, so you know what? Let's keep running through our example. So we're here. We're at 2, 2, 2, 5, 5. Here, this is where the first instance in which it should happen. We'll take a look at the left and right pointer over here. Where would this issue occur? Right, okay. Let's do a print statement and check to see what's going on after you do the initial run through of here. So we'll just print out current sum. What this should return as a output is 6 for the initial first case. Yeah, so it should be 6. And then for every single subsequent one, what's going to happen is we're going to go ahead and check the result. And we'll print out the current sum and see what's going on again. So we have 6, and then yeah, we print out 6 again. This time 6 yeah, divided by k greater or equal to the threshold. Then we go 9, 12, and 15. Actually, let's go ahead and print out the divided by k in order to have a better idea what's going on here. So 4 is being caught, 5 is being caught, but 6 isn't being caught. So it's that final case which is causing the issue here. Has to do with the while loop. but this causes the sliding index to be out of range. Okay. So this has to do it for the final one, but this can only be valid. You're only allowed to do this if r is less, if r is less than the length of the array minus 1, because you're incrementing this forward for the final iteration, and you want to check to see whether or not this is valid before doing so. So we'll go ahead and run this now. Accepted. Okay, perfect. We'll go ahead and run this final submission. Five test case passed. Okay. So here k is equal to 1, threshold is equal to 0, and the output is 4 when it should be returning 5. Right. So we have k is equal to 1, 1, 2, 3, 4, 5. Average is 1, average is 1, 2, 3, 4. The final one. Let's have a look here. Okay, so we'll run it through with the algorithm again. We have basically one. We start off with the left pointer at 0, right pointer is at 0, and we traverse through for up until k. K is 1. So yeah, at the very beginning, what it does, it'll print out cursum, which is 1, the average of it, before moving on to the next one. Now it does this again. So this one, yeah, okay, so this prints out 1. Print out cursum. I see. Try running it with this. Or, sorry. Go ahead and run this again. Right, okay. That makes sense, because we also have to include the final value here. Oh, okay. So there are some edge cases over here. We can take a look, where the final value is a negative number. Why is that? Because k is equal to 1 and threshold is equal to 0. If the threshold is equal to 0, then it should contain every single value, right? So if we do cursum divided by k, whether or not that's greater or equal to the threshold. Okay, this makes sense. I see. 3 more test cases before it works. Okay, let's run this through this example again. We'll have 1, 1, 1, 1, k equals 1. K equals 1. We start off with a pointer here, and we start off with a pointer here. We traverse it forward, threshold 0, it stays here, figures out. Yeah, figures out what the average at this one is. So I see. So the issue with the for loop, basically when you're like when you're starting at the very first position here, like if k is equal to 0 for I in range 0, it's not going to run at all because there's like no threshold basically for it to like go through, right? But you still wait, case still equal to 1, sorry. The threshold is 0, so this, yeah, it was working as intended. So 1 1 1 1, we keep traversing the left and right forward, 1 1 1 1. But this, for some reason, is a negative 1.0. And why is that? So for the last value, let's imagine, where's the left pointer and the right pointer? Basically, it's here, and the right pointer, I see. The right pointer might, like as you move that right pointer here, well, the if statement should catch to see whether or not it's valid or not. So the right pointer will stay over here. And for some reason, this returns -1. Oh, I see. Because this one might not be even adding anything. So we only want to move the window forward for both, pretty much like for the left and the right. If we can move both of them. If we can only move one of them, then we shouldn't be able to do anything. Yeah, we'll go ahead and run that. That should fix that test case. Okay, I see. Okay, another issue over here. Output is 4 when you expect 3. 2 2 2 5 5 5 8. I wonder if there's another way in which we can modify this while loop in order to have it so that like this can be condensed into one place. Let's have a think. What if we rearrange this so that okay, so basically you do the incrementation first. Oh, okay, wait, because then you're missing this case actually. Hold up, let's think. Check to see first whether or not it matches the threshold. If it does, then you add to the result, and then what you want to do is you want to move the sliding window forward only if it's the right one is less than, not the array, or less than or equal to, maybe. Go ahead and do that. Oh, sorry. Oh, right. Okay, hold up. Two of our original test cases aren't working. Let me play around with this a little bit more. Let's move it back to its original state and see what's going on. Right. Interesting. We'll go ahead and submit this again just to check what's going on here for that. It should be the same long answer one. Yeah, 66. Okay. So for this issue, it's because this sliding window is moving forward up until where it's a non. Okay, let's think. Why is this -1? It's because, okay, curse, we want to figure out what curse sum is at this given point. So let's do prints curse sum, and then we'll do prints k in order to figure this out. So we'll go ahead and get rid of this statement here. Curse sum is equal to that, and k is equal to this. Go ahead and submit this. Okay, hold up, give me a second. Okay, so we'll switch this to a string, and we'll switch this to a string as well. Might take a while to load. 66, okay. Curse sum. Want to open the variance. Okay, so for this one, yep, k is always equal to 1 as usual. And then curse sum is equal to -1 because at that previous iteration before it's equal to 0. Oops, sorry. It's equal to 0. And yeah, it's like we did before. We pretty much moved through we checked to see whether or not the length of the array is subtracted by 1. So went on to that. Right. And then here, let's do, this shouldn't make a difference. But let's go ahead and make these equal to each other. Right, okay. Less than or equal to length of the array -1. Edge cases. Let's have a look. So this case, okay, so we have two more test cases over here, and k is equal to 3, and curse sum goes from 21 all the way to 16. So since k is equal to 3, it goes from 15, right, to 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Interesting. The current sum is, yeah, okay, I can see where this is coming from, right? 5, 10, 11, 12. It goes to 15, so 5, 10, 15. And then from this one, moves forward once. This becomes 21. 5, 10, when it should be 18. Now, why is that? Let's take a look. So what's the difference? 18 minus 21. That's a difference of 3. K equals 3. Left and right equals L plus 1 and R plus 1. Okay. Run this through again. We start off at 6, right? Then we start off. Okay, we'll put the raw text here. Start off at 6. Yeah. 2, 4, 6. Interesting. And then we end up at 2, 4, 6. It should still be 6. So 6 and 6. Go ahead and let's move this curse sum. Let's move this again. Right, so we'll open this again. So we'll start off with curse sum 6. Yeah, 6. And this goes here. 5, 6, 7, 8, 9. And then we go this. 5, 10, 11, 12. Then we go this. 15. And then we go this. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Should be 18, but it's showing up as 21. And also, it's starting off at index 1 for some reason, when it should be starting at index 0. So we traverse the right pointer forward. So the difference between R minus L. You know what? Instead of doing this, maybe we'll do while R minus L while not R minus L is equal to K. While this is not the case, we increment this forward. Pretty much we add this to the so curse sum, you add that by the amount of the right pointer, and then you move that one pointer forward. So while this isn't the case, and where it's not inclusive. So we'll start off at here. Okay, actually we'll go here. So we start off at 0, 0, while it's not equal to K. Nope. So we move this forward. K is equal to 3, so nope. This is index 1. This is at index 2. 2 minus 0. Yeah. And this is at index 3. 3 minus that is it. So we'll do so while not R, right, which is 2, minus K. So I'll have to do K minus 1. Let's go ahead and run this again. Okay, wait, no. Wrong logic, I think. Okay, yeah, R minus L equals K. Okay, so this is the same logic. Still running across the same issue this time, though. Okay, let's keep looking at this. So K equal to 3, K equal to 3, yep. So 6, yeah, it starts off at 6. It starts off at 9. Let's check what where the indexes are at this given one. So L equals plus stir L, and I'll do R equals stir right. You know what, we'll move the K since we already know what that's going to be. Go ahead and submit this again. Taking a while. Okay, let's open the raw again. Yeah, so left is equal to 0, this is equal to 3. L is equal to 1, 4, 2, 5, 3, 6, 7, 5, and 8. Okay, we start off at 0 and 3. Adding up those all together, that's 6, as it should be. And then from 1 to 4, so 1, 2, 0, 1, 2, 3, 4. Interesting. 5, 6, 7. 0 and 3 is 6. And then 1 to 4. 1, 2, 0, 1, 2, 3, 4. R equals 4. go ahead and move this. Let's have a think here. Huh. Why does this return curse sum equals 16? One, two, three, four, five, 6, 7, 8. So this is 8. Hmm. 0 and 3, right? Then we do we go ahead and have that check, right? And then let's go ahead and remove the left one and then add the right one. Before traversing them forward. Right. Okay. Right. That makes sense. Yeah. So my logic before was incorrect because like my original thinking was that for the left one you'd have to decrease that and then move all the iterators forward, adding the new one onto it. Where in reality we should have just added it makes more sense to add the element like where the right pointer currently is before incrementing all of those together. But yeah. Okay. So yeah, that's my accepted submission. Thank you guys for watching, and yeah, I hope you liked my new format of the video, by the way. So usually what I've been doing for my videos before is I've been basically trying to solve the problem on my own before the video happens, and then at the video's very end, that's when I re-explain it to everyone and explain like what I'm doing. What I'm going to do now is like pretty much just like try to solve it raw in the video so you can see like my thought process as I iterate forward through the whole thing. But yeah, thanks for watching.